Using our angles that are formed by our parallel lines and our transversal, we can also prove that lines are parallel. So we're sort of going the opposite direction this time. When we do that, we're using the converse of each type of angle. So the converse, if you remember, is that we are switching those terms. So when we were finding our missing angle measures, we used the fact that the lines are parallel. That means that our angles are congruent or supplementary. Now we're switching it. So now we're saying the fact that they are corresponding angles, or if they're alternate interior angles, and whatever that relationship is, then those lines are parallel. So looking at the corresponding angles converse, we are going to use the picture on the left. It says that if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So an example from our picture is if angle 1 is congruent to angle 5, then line L and line M are parallel. For alternate interior angles, it's saying that if we have our alternate interior angles that are congruent, then our lines are parallel. So for our example on the side, if angle 4 and angle 6 are congruent, then line L and M are parallel. Alternate exterior angles converse, if we have alternate exterior angles that are congruent, then our lines are parallel. So our example from the side is if angle 2 is congruent to angle 8, then line L is parallel to line M. For consecutive interior angles converse, if two angles are consecutive interior angles, those are our same side interior angles. If they are congruent, then our lines are parallel. So an example of this would be if the measure of angle 3 and the measure of angle 6 add together to 180 degrees, then line L is parallel to M. So remember, when we have those same side interior angles, our angles are supplementary. So in this case, it's not congruent. This should actually say if they are supplementary. Our last example or type of angle is our consecutive exterior angles converse. And that's saying that if two consecutive exterior angles are supplementary, then our lines are parallel. So that our example would be if the measure of angle 1 plus the measure of angle 8 equals 180 degrees, then line L is parallel to M. So we're still using those same types of angles. We're just flipping the order, and we're looking at the angle measures before we say the lines are parallel. If we look at a few examples, with this we are going to see if we can say that the lines are parallel, and if so, which converse we're using. For example number 1, we have 63 degrees in each spot. Those angles are an example of our alternate exterior angles. So we can say that yes, these lines are parallel using the alternate exterior angles converse. We have to make sure we actually write the word converse when we're trying to prove that lines are parallel. For number 2, if we're looking at our picture here, those angles are corresponding. Our corresponding angles are congruent, which is also what's marked in the picture. If we just have one arch in each spot, that means they are the same. So we can say, yes, this is parallel using our corresponding angles converse. For number 3, we were given a 48-degree angle and a 132-degree angle. They're on the same side of our transversal, and they are exterior angles. So if we have alternate exterior angles, then those angles would need to add up to 180 degrees. So if we add 132 plus 48, we find that that is 180 degrees. So we can say yes, using our consecutive exterior angles converse, or that same side exterior angles converse. For example number 4, we see that they gave us two angles that are 105 degrees. Those are examples of vertical angles. When we're trying to figure out if lines are parallel, we actually can't use vertical angles as a reason. It doesn't tell me anything about line L. And that's what all of our other angle relationships use. They use both lines. So in this case, we would say, no, these lines aren't parallel because based on the angles that were given, I can't say that they were. Number 5 in my picture, we have alternate interior angles. They are marked as congruent, so we can say yes with our alternate interior angles converse. Number 6, we have our same side interior angles or our consecutive interior angles, which means our angle measures would have to add up to 180 degrees in order to say that these lines 125 plus 65, we find that that measure is 190 degrees. Since it's not 180, we would say, no, these are not parallel. Again, it doesn't match what my angle properties tell me. Looking at some more examples, we're going to use the picture on the left for all of them. And it's asking which lines would be parallel and what our converse is if we say that they are parallel. If we start with angle 2 and angle 4, we see that line A is used and line C and line D. 2 and 4 don't have anything to do with B, so we can basically just cover that part up. When we look at angle 2 and angle 4, the lines that would be parallel in this case are line C and line D. In this case, A is our transversal that's cutting through our parallel lines. The angle property that tells me this is our corresponding angles converse. Notice that converse is at the top, so we didn't have to write it in the bar, but we do want to make sure that we know that's the converse. Looking at 5 and 10, 5 and 10 deal with line C, line A, and line B. We didn't use line D at all. In this case, C is our transversal. It's cutting through A and B to give us that angle 5 and angle 10 are congruent. So our parallel lines are A and B, and that is our alternate interior angles converse. For letter C, we have that angle 1 and angle 13 equal 180 degrees. Looking at that, we are using line A and line B, and line C is our transversal. So A and B are our parallel lines, and that is our consecutive exterior angles or the same side exterior angles. If we look at angle 1 and angle 14 that are congruent angles, the lines that would be parallel with that are A and B again. C is our transversal. And that is our alternate exterior angles converse. For angle 14 and angle 15, adding up to 180 degrees, line B is our transversal, and C and D are parallel, and 14 and 15 equaling 180 is our consecutive interior or same side interior angles converse. For F, 11 and 16, if we look at those, 11 and 16 are vertical angles. So remember, vertical angles, we cannot say that they're parallel lines, so we wouldn't have a converse. For angle 4 and angle 15, D is our transversal, and A and B are our parallel lines, and 4 and 15 are our alternate exterior angles. For 10 and 12, line B is our transversal, and C and D are parallel, and 10 and 12 are corresponding angles converse. For letter I, we have 9 and 13 equaling 180 degrees. Yes, that is true. Yes, they are supplementary angles, but that doesn't tell me anything about whether my lines are parallel. So that's another none. We can't say anything, so there is no converse. Angle 2 and angle 7. Line A is our transversal, and C and D are parallel, and they are alternate interior angles. For angle 6 and angle 11, we see that they don't share the same transversal. 6 is dealing with line C, and then 11 is dealing with line D. So we're going to say that there is none, and there's no converse needed. Example 8 is done the exact same way as example 7 that I just walked you guys through, so I'm just going to show you those answers. Notice for this one we do have 3 different lines going down, so P, Q, and R, and then S and T would be those transversals. The last thing to look at for these set of notes is that we also can use the transitive property when we're talking about parallel lines. So with our transitive property for parallel lines, it says that if 2 lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q and Q is parallel to R, I can take out that middleman of Q and just say that line P is parallel to line R. If we look at the example down below, it says that if A is parallel to C, state which other lines are parallel and why. So notice they did give us some angle measures in here, and we can use those to figure out what other lines are parallel. So we know that A is parallel to C. So the first thing that we can pick from this is that line B is parallel to line C because we have consecutive exterior angles that are supplementary. So our same side exterior angles. Then the other thing that we can look at is because A is parallel to C and B is parallel to C, I can say that A is parallel to B using that transitive property. So that's finding whether our lines are parallel using those same angle properties. Again, when we do this, we're using our converse. So we're saying that if the angles are congruent or supplementary, then we have parallel lines. And we want to make sure that we say that it is the converse.